try to make this large enough. Go ahead, Claire, give us a little first paragraph reading there, please.
As you now know, Newton's laws describe the relationship between an object and the forces acting upon it and the object's motion in response to those forces. Multiple forces pushing and pulling on a plane affects the plane's speed and direction.
Excellent. Little reflection question. One of these four forces affects every object in the universe, including on things on Earth, including you. Can you guess what this force is? Go ahead and type it in the chat if you think you know what the force that affects everything on Earth and in the universe is. Type it in the chat if you know the answer to this reflection question. 2 of you know it. 3 of you know it. 4, 5, 6, 7. And it is indeed gravity. So one of the four forces of flight you're already familiar with. And it's gravity, they list it in a different way. They call it weight, which is what Hunter Moss put in. But it is very closely connected to gravity. So let's take a look here. Joey, can you read this paragraph?
There are four forces of flight: lift, weight, thrust, and drag. These forces make an aircraft move up and down, and faster and slower. The amount and the direction of each force changes how the aircraft moves through the air.
Excellent. So when we look at this, most of you put in the word gravity. Hunter actually wrote weight. Without weight, gravity wouldn't affect you, so everything that has weight is affected by gravity, but they do call the four forces lift, weight, thrust, and drag. So I've got an airplane here, and I'm just going to play a little guessing game. Out of those four forces, which one do you think is represented by this arrow that I just put a circle around? Go ahead and type your answer in the chat. It's either lift, weight, thrust, or drag. Seven people have all answered lift, and they are all correct. And it's pretty simple if you look at that, because lift is going up, right? So it's not something where you have to be too technical, right? I want you to understand that a lot of this just makes common sense, not special sense, just common sense. Let's take a look at another one. Look at the way the airplane's going. What about this arrow? We already got lift, so is this weight, thrust, or drag going forward? Weight, thrust, or drag? And I'm seeing a lot of people. Claire said drag, and everybody else said thrust. Claire, can you tell us why you thought drag might be what's going on here with the circle that I made?
Well, I kind of got them confused. I feel like drag would be the arrow pointing left, and thrust would be the one in the front. I got confused.
Yeah, it's not confused. We didn't teach this yet, so you were guessing. That's okay. This is moving forward, so these arrows represent the plane. Thrust is the force that moves the plane forward. Now, thrust comes out of the back of the plane, but it moves the plane forward. So that might be where your confusion is, right? Thrust comes out of the back of the plane, but it moves the plane forward. So there is some understanding in being confused as to what the question is asking there. If you remember, who can tell us who's got the memory to last perfectly corresponds the explosion in the engines, both in it's actually underneath the wings. I was pointing back here like it was a rocket. The engines are underneath the wings. The exhaust that's coming out when you have the engines turned on is going to the left. The opposite reaction is it's thrusting the plane forward to the right in this picture. Okay, so we have two more, and it's getting easier when the when the options draw down. But if thrust is going forward, drag is what pushes against the plane. Now, the drag is caused by, somebody said air pressure. It's not air pressure, it's air resistance. Air resistance is pushing against the plane. As the plane goes forward, it hits the air. And just like Newton's third law of motion says, when it hits something, there is an opposite reaction. The air is actually hitting back on the plane, pushing it backwards. So you want to equalize thrust and drag to make your plane go steady. And then the last one is weight, which is the same thing as saying, it's not the same thing. It's similar to the concept of gravity. Gravity is the force that pulls you down. Okay. Any questions so far? Groovy. Let me turn my writing tools off. Hudson, can you read this paragraph here, please? Starting with the word all.
Sure. All forces have both a strength or magnitude represented by a number and a direction, represented by an arrow, plus or a minus sign, in which they are exerted. For example, the force of gravity's magnitude is how strong its pull is, and its direction is toward the center of the earth.
Okay, thank you very much. I'm going to make a really bad, I shouldn't say really bad, I'm going to make a really basic paper airplane, because the last time I went to school 2 Wednesdays ago, I took my styrofoam gliders in, and I don't have them with me to demonstrate, but actually, you know what, I'm not. I'm just going to use the straw jet, because that's what we're making next week. So, all they're saying here, weight. Lift is the upward force that enables an aircraft to raise off the ground and remain in flight. It works against the downward pull of gravity on the aircraft called weight. There is an entire chart here to explain what they are. Lift is created by the difference in air pressure and the movement of air around the airplane. So, lift happens because something called Bernoulli's principle. They changed this course this year to not do a full explanation of Bernoulli's principle. If anybody wants to know more about it, they're welcome to ask me about it. But for now, just understanding this much, lift is created by the difference in air pressure and the movement of air around the plane. The way the plane is shaped, the way the wings are shaped, causes the air to push the plane up. Weight is caused by the Earth's gravitational pull on an object. Lift magnitude depends on several factors, and I just mentioned some of those. Weight depends on several factors. The bigger the total mass is, the bigger the magnitude of the weight. Lift pushes the plane in a direction perpendicular to the direction the airplane is flying. Weight pulls the airplane towards the center of the Earth. And none of these are constant. As you fly, you burn fuel. Your plane gets lighter, so you don't need as much thrust to maintain the same amount of lift that you did when the plane was heavier. Okay, we're not going to do this one. We're going to do it differently. Thrust and drag. Let's see. Addie, could you read the first paragraph that starts with the word thrust, please?
Force that propels an aircraft forward is opposed by drag, the force of resistance that works against the forward movement of an aircraft through the air.
Excellent. When an airplane moves through the airplane pushes against the air, and the air pushes against the airplane. Newton's third law of motion. The force applied by the air onto the airplane's surface is the force of drag. You may have experienced drag when riding your bike or putting your arm out of the car window. You can feel the force of it pushing back on you as you move through the air. How many people have done that, putting their hand out? The two diagrams here, and to make sure that we clear up Claire's confusion, the thrust comes out of the back of the airplane, but it pushes the plane forward. That's why the forward arrow is considered thrust. And even though the air resistance hits the front of the plane, it pushes the plane backwards. So these arrows are not showing which way the thrust of the air is. It's showing which way the plane is going as a result of these two forces, thrust and drag. We already said that. Drag is basically air friction. Thrust depends, the magnitude depends on the type of engine, the number of engines, and how much gas you're burning in those engines, which is called the throttle. And drag includes the shape and size of the aircraft, the speed of the aircraft, properties of the air. So your drag is different if you're in a storm than it is on a clear day where there's no rain or anything about, right? So there's a lot of different stuff happening there. The direction, thrust propels or pushes in the direction of motion. Okay, and that direction depends on how the engines are attached to the aircraft. Drag pushes against the direction of the airplane's motion. Let's do a 3-question check for understanding. Okay, let's see. Madison, thrust. Tell me where to drag the letter A.
The arrow in the front of the plane.
A little bit louder.
The arrow in front of the plane.
The arrow in front of the plane. Boom. All right, lift. Ella, tell me where to drag the B arrow.
To the arrow pointing up.
Weight. Connor Martin, tell me where to put the weight arrow or the weight letter.
The arrow pointing down.
Okay, Nicholas, if everybody else is correct, where should I put this one?
The arrow pointing to the left.
Okay. Oh, there we go. Next, fill in the blank. Everybody type in the chat. The force, the first person to get it right in the chat gets 10 points, Falcon Pride points. The force of blank opposes the force of thrust. We have such a beautiful, smart class. Cohen's got it, Hunter's got it, Joey's got it, Madison's got it. So I'm going to type in the word drag. Hunter, you get the 10 points. As a matter of fact, for participating, Cohen, Joey, Madison, Claire, and Samantha, you're all going to get points too. Cohen, Joey, Madison, Claire, Samantha. I like to give some points for first, but I want to make sure everybody gets points for participating. Fill in the blank, same thing. The force of blank opposes the force of weight. Rianne, nice job. We got Joey, Cohen, Hunter, Hudson. Joey, Cohen, Hunter, Hudson, Claire, Madison, Samantha. Claire, Madison, Samantha. All right, you all get some nice Falcon Pride tickets coming up. So lift opposes weight. Let's see. Do we get them all right? Yes! Yes! All right. Look at this class. Woohoo! Woo! Wow. We'll skip all that and we'll do some practical stuff. Okay, I'm going to stop that. I'm also going to stop